Okay, this video is about creativity as seen by Genrikh Altshuller. So Genrikh Altshuller, this is him as a young man. He grew up in Russia, and he was a very clever guy, interested in engineering and that sort of thing. He had been imprisoned by Stalin for a while. When he was in prison for 4 years, what he did was study all the time. At least he was allowed to have books, and he found a couple other smart, like-minded comrades. He said things like, you can't jump up 5 meters, but you can build several small intellectual steps that enable you to climb up 5 meters, okay? He became well known around the time of World War II in Russia for his skill in fixing machines. And then he got a job in a patent office, and he started studying patents. It kind of reminds you of Einstein, but he started studying patents, and he went through many thousands of patents, and he really tried to understand what was the invention being patented. And he came to the conclusion that 98% of the patents were really just applications of old methods to new situations. Only 2% were really new ideas. And he decided to make a list of the 40 most common ways that engineers solve problems. And he says that typical engineering problems involve a technical contradiction, that when they improve one part of the machine, for example, the second part gets worse, and so the two trade off make it so that you can't fix the machine, you can't improve it. And he says a good solution is figuring out a way to improve both parts simultaneously, or at least not make one part worse while you improve something. And he said, basically, he summarized the 40 most common ways that engineers had done this, and he says that when an engineer encounters a problem, they can just take a look at his list of 40 most common solutions, and quite often that will enable them to solve the problem very quickly in a matter of days, rather than, for a lot of these technical problems, it'll take engineers, many years or decades to solve the problem. He says, here's a list of the way it's been done before. And what I would say is, engineers can just look at his list of problem-solving techniques used in the past. And I would say we can apply this. This is a picture of him working on another machine, and he's a little bit older. We can apply this to nutrition. For example, I would say the first thing you have to look at is what is the author's secondary gain. If they have a secondary gain, quite often the paper's bogus, okay? For example, who funded the paper? If it's funded by industry, it's always going to praise their thing. They wouldn't publish it if it didn't. Don't get me wrong, there sometimes might be some validity to it, but usually it's bogus. If what they were saying was really true, they wouldn't need to fund it in general. Does the author have big secondary gain? If the author is selling the thing they're promoting, then, maybe there's secondary gain there. There often is. Not always, but there often is. Okay. Then you start looking at other things. What independent correlates can you get? Does it correlate with epidemiology? Does it correlate with your own personal experience, with the experience of your friends, your patients, your clients? Another good question to ask yourself, I found this very helpful. As strange as it sounds, this has helped me to solve problems in tons of situations. Somebody is saying something, and I ask myself, what is the rule of... Well, first I'll give you 2 quotes. One is the quote of Ayn Rand. Ayn Rand said, there are no contradictions. If you sense a contradiction, you must recheck your premises. And I find that is true all the time. That the reason why there seems to be a contradiction is because the other person is BSing you, okay? And it goes back to the quote also of Thomas Carlyle. He said, when an expert gives you an opinion, there's usually always a good reason, and that's the one they tell you, but quite often there's another thing that is the real reason. So always ask yourself, okay, I hear the so-called good reason that they're telling me here, but what's the real reason for this? What's the real reason they say that? You'll be amazed how often that gives you the answer very quickly. And the other thing I found very helpful is I always ask myself, what if the opposite was true? And I just sort of play out a scenario in my mind of the opposite being true. And if the opposite makes sense, then it's probably true. And if it doesn't, then it's probably not. And I also like the quote of John Boyd, the great American genius guy, engineer on how to build planes and whatnot. And he said, if you want to get a sense of what an idea really means, extrapolate it out to its extremes. Like let's say they recommend making a change in the angle of the wind flap on a plane wing. He goes, well, just extrapolate it, make it giant, and then see what would that do. And when you apply that to regular human situations, a lot of times that is really helpful. And I also will ask myself, like in personal situations, like when somebody says or does something towards me, I say, how would they feel if I did that towards them? And a lot of times that really tells me why they did what they did or what they're getting at. Okay, so anyways, the other things I would ask myself when I read a paper about health or nutrition is, does it make sense with what's known about biochemistry? Is there a plausible mechanism for this? Does it fit? Does it open up a series of connected events that make sense? Does it correlate with animal studies? So anyways, I thought this was interesting, very clever. Altschuller's method of making a list of common technical solutions that people can refer to when they encounter an engineering problem. And then those are mine right here for nutrition and health questions. I hope that was helpful.